Hello, how are you? Good day. So today we're going to discuss another topic in physics, that is kinematics. Okay, so in physics, there are sub-branches of physics, and these are the first one, which is very common, is the classical mechanics, or commonly mechanics. So you have classical mechanics, and others would be, for example, there are other branches, for example, thermo, I'll just use a symbol. So you can have thermodynamics, and sometimes it includes statistical mechanics, StatMech. And also you have electromagnetism, EM. So here it includes electricity and of course magnetism, and also an introduction to electromagnetic waves. And you have, of course, there are other sub branches of physics, quantum mechanics, and yeah, there's a lot more. So we'll just call it etc. And it will not be discussed today. So what we're focusing here today is the branch of mechanics that is kinematics, which deals with motion. So mechanics can be further classified into kinematics and dynamics. Dynamics. And sometimes there's also what we call the statics, but we're not going to statics discuss that much in detail. Okay, so let's start with kinematics. Okay, so in kinematics, this is the sub-branch of physics that deals with describing motion. Describing motion. So how do we describe motion? So here you will encounter quantities or terms such as speed, or we can use a symbol S for speed. We can also have displacement, delta x for our displacement, or velocity, and also acceleration. So these are the common terms that you're going to encounter in kinematics that you are going to use to describe motion. So what is distance? What is displacement, speed, and velocity? Okay, so perhaps I'll show you a video or a demo. So here you have a fire truck, and let's say the fire truck starts at the 0 mark. Okay, so the fire truck is starts at the 0 mark. So now it is at rest. So the velocity, the speed is 0. Now, if the fire truck starts to move, after some time, it has a velocity, it has a speed, okay? So it's moving now, so it's changing its position per unit of time, okay? So you can use a timer. And in a way, it's also important for describing motion. Time is also important for describing motion. And so we have distance, the length traveled or the path traveled, and displacement concerns with initial and final. Okay, that's displacement. So here, initially the car is here, this is the initial position, and then later on the car is here, this is the final position. And that is displacement, final minus initial. Distance is the path traveled. Sometimes it can go this way, so it can be longer than the displacement or the magnitude of the displacement, but they can also be equal. So if the object just, or the fire truck just moves straight line, so as you can see, displacement is the same as the distance. So they can be the same. Okay, but what if the car is moving in a different speed? Like it is getting faster and faster as time passes by. So in our language, pabilis ng pabilis. The velocity increases, pabilis ng pabilis, it's getting faster. So it is what we call now acceleration. So what we have, velocity, okay, speed, distance, displacement, and acceleration. So these are the terms that you are going to encounter in kinematics. Okay, so let's continue. Okay, so what we had earlier are that is the track moving along a straight line along the horizontal, and then what is the distance, displacement, speed, and velocity in this situation, and acceleration as well. Okay, so we define distance as the path traveled. Okay, so let me write it. It is usually the path traveled, the length of the path traveled. Okay, and so it depends on whatever direction along the motion. Okay, so perhaps the car can move that way, that way, that way, and so on until it hits until it reaches the final position. So it can be longer, you know. Okay, so this is the path traveled. So we just call it capital D for distance. And of course, the unit for distance is in meter. Now, what is displacement? Okay, it's the change of position. So it's a change of position. Okay, and we denote it as delta. So let's say you have x naught here, x naught meaning the original x, original position. And let's call this as x, or the final position. Okay, sometimes other books call it xi, and then for the final position xf, but I'll just call it x naught for original or initial position, and for the final position x. So it's change of position, and change is delta, delta x. That means, let me move that. Delta x means the final minus initial position. And of course, the unit for displacement is also meter, same as the distance. Okay? But what is now speed? Speed is the traveled, distance traveled over the elapsed time. Elapsed time. Okay, so distance traveled over the elapsed time. Let's call it S. And that is distance over delta t, or just call it t, distance over time. And the SI unit for speed is meter per second. Okay, so the car moves per unit of time, so we have the time of travel. And what is now velocity? Velocity is defined as displacement over the elapsed time. Okay, so it's displacement over the elapsed time. And we use a symbol V. Actually, it's the average velocity. So V equals displacement delta x over the elapsed time delta t. And the SI unit for velocity is meter per second. Okay, it's similar to the unit of speed, right? We've noticed that here. And now what is acceleration? Acceleration is defined as the rate of change of velocity. So rate pertains to time. Rate of change of velocity. Let me erase that one. Rate of change of velocity. Okay, so here we use a symbol A for acceleration, that is rate of change delta V, rate of change per unit of time over delta t. And the SI unit for acceleration is meter per second squared. So these are the kinematic variables that we need to use, that we usually use to describe motion in kinematics. Okay, let's have an example. So let's say our truck moves, siren. After some time, it is now located in this location. But let's say it started at rest. So let's say the initial velocity, let's call it V naught equal to 0. So it means it is at rest, okay, at the initial position. And then after some time, let's say after 5 seconds, because it's an emergency, it's now getting faster and faster. Now the velocity is, let's say, I don't know, 60 kilometers per, okay, per hour. Let's say 60 kilometers per hour. Okay, I'll just use H for R for my symbol. Okay, what is the acceleration? So that is required. So we can write our given. So here the given, usually it's word problems, but I just said it to you, oral. And then, so you write the given variables. V naught is equal to 0 meter per second. The V final is actually given, but it is in kilometers per hour. So it's 60 kilometers per hour. What you have to do is convert this into meters per hour, okay, for SI unit. So for every 1 kilometer, there are 1,000 meter. And then for 1 hour, there are 3,600 seconds. Or you can also convert that into 1 minute, 60 seconds, 1 hour, 60 minutes. But I just do it shortcut. For 1 hour, 3,600 seconds. So here you can cancel out some units. The kilometer can be cancelled. The R can be cancelled as well. So what is left is meter per second. So the velocity is also given 60 times 1,000, 60,000 divided by 3,600. You should be able to get an answer of about 70 meter per second. Okay, and the time is also given, and that is 5 seconds. See, your time is in seconds. You really need to convert that into second. And of course, the required is acceleration. So what is acceleration? Now for your solution, what you're going to do is choose the right equation. So which equation are you going to use here? Of course, equation number, well, the equation for acceleration, right? By the way, this means final velocity minus initial velocity over t minus t naught, or you can just say t. T naught is initial time, which is usually 0, so we don't bother about the initial time, it's 0. And then, excuse me, this one is also x minus x naught over t. But take note, x naught is usually at 0 mark, so sometimes you can just have x over t. So let's go back to acceleration. Acceleration is delta v over delta t. Okay, acceleration is delta v over delta t, which actually means v minus v naught over t minus t naught, or just t because t naught is 0 anyway. So just substitute the value now. So you have 17 meter per second minus 0, so 0 meters per second, so it doesn't matter, over the time, which is a 5 second. Okay, so you should get an answer of, what is it, 17 divided by 5. You can use your calculator. Okay, and I was able to get 3.4 meter per second squared. So this is my acceleration for this example. So what does it mean? It means that for every second, the velocity increases by 3.4 meter per second. Okay, so it means velocity increases, velocity increases 3.4 meter per second every second. So it means the fire truck is getting faster. At 1 second, 3 meters, 3.4 meter. After another second, faster, faster, and faster. Okay, so perhaps let's have, I don't know, another example. So yesterday I was riding the MRT going to the BGC area and then coming back. So I just decided to do some recording of the values, and that is the time. I record the time from GMA Kamuning Station up to Quezon Ave, and later on I measured the distance from GMA Kamuning Station to Quezon Ave using the Google Map. Okay, so here is the problem that we're going to do. Okay, so this is the problem. What is the average velocity of the MRT train starting at GMA Kamuning Station to Quezon Avenue Station? So when it starts moving, I started my timer, stopwatch. So the total travel time is 2 minutes and 22 seconds. And the distance from that station is about 1 kilometer. I just measured it approximately in Google Map. Okay, so I just measured the time. So 2 minutes and 22 seconds. So when you're solving problems like this, word problems, write the given variables. Okay, so take note of the problem. We will go to another screen. Okay, so here are the given. So what are the given? The given variables, I started at time 0 and initial velocity is 0. So the train starts to move, so initial velocity is 0 meter per second. So we don't actually know the final velocity, right? So perhaps in the driver's seat you can determine, but yeah, we're just a passenger. So we don't know actually. So what can we get is the time, and the time travel is about 2 minutes and 22 seconds. So this is in minutes. You need to get the value in second. So we have for 2 minutes times in 1 minute, there are 60 seconds. And then you just add the 22 second. So the total time of travel is about 142. Yeah. So it's 120 plus 22, 142 second. So this is the total travel time. So I'll just use this as per second. And then the distance, I was able to get the distance or the displacement from Jimmy Kamaning to Quezon Ave is about 1 kilometer. Or you can say 1,000 meter, more or less. Okay, so what is the average velocity? So actually, we don't need a value of 0, right? So for our solution, so we define the average velocity as, what is it? If you're going to recall your set of equations, average velocity is delta x over delta t. So that's the equation that we're going to use. Delta x over delta t. And delta means change, so it's x minus x naught, and then t minus t naught, wherein again, our initial position is the GMA commoning. We appoint it as the 0 mark. So we don't need to write it. And of course, we start at time 0, so we don't need to actually write t naught. So basically, what you can have is x over t. And we have the value for x and t. Okay, the x is 1 kilometer or 1,000 meter, and the time is 142 second. So the answer here, using your calculator, you should get an answer of, please do so. I might make a wrong answer. In the other video, I made a wrong answer. So a good thing one of my student and our subscriber here noticed it. So I was able to correct it in the comment section. Okay, so you should get an answer of about 0.0 meter per second. So that is the average velocity of our train. Amazing, right? You can determine the velocity of your train. Okay, so it changed a little bit. This is average. This is not the actual at a specific time. So the actual is what we call this instantaneous velocity, but we're not going to discuss it here. So, but this is just the average velocity. It's the average velocity as it traverses all throughout the length of travel, that is 1 kilometer. Okay, so if you have questions or examples that you want to do, perhaps you can leave it in a comment. In the next video, we're going to discuss the kinematics equation and the derivation of the kinematics equation.